In our next example, we'll investigate this idea of investing early and the impact it can have versus investing later using two scenarios for something very similar. Let's say you decide to use $1,000 of a work bonus to open a retirement account that earns 5% compounded monthly. Now, in scenario one, which we'll start with, you take that $1,000 that you start with, you put it in, but you also deposit $160 each month for 10 years into this retirement account. Now, after 10 years, you're going to make an adjustment. You're going to actually stop making the monthly payments, but leave that money that you currently have in the account for another 20 years. What we're going to investigate is how much we would have in total in the account after 30 years. Scenario 2 is going to be a little different, but it's going to have the same type of thing going on, starting with $100,000 and depositing $160 each month. But how we deposit that $160 is going to be different. But let's work out scenario 1 and the amount we have after 30 years first, and then we'll look at scenario 2. So there's two different things happening in scenario 1. We have something happening in the first 10 years, and then we have something happening in the remaining 20 years. Something different. So we need to look at both of those situations. Okay, so let's start with in the first 10 years. In the first 10 years, you've deposited $1,000 and you have then taken $160 per month and put it in the account. So we could work out the future value at the end of those 10 years by going equals FV in our spreadsheet for future value, putting the interest rate per month, which would be 0.05 divided by 12. Then the number of monthly deposits you're going to make, which is 12 times 10, because we're only going out 10 years here. We started, our monthly payment is $160, so we'll enter that next. And then we're starting with 1,000. That would be our present value. So when you use a spreadsheet to calculate out, and here I'll show a screenshot from me doing that, we actually get $26,492.17 in the account after 10 years. So $26,492.17. That's what we have after 10 years. But remember, we want to go out all 30 years. So we need to include the next 20. We're still looking out into the future, so we're still going to use the future value formula. But in those remaining 20 years, those next 20 years, we're going to stop the monthly payments, no monthly payment, but we're going to keep the money there. So we have $26,492.17 in the account. It just stays there and continues to earn interest. So our interest rate doesn't change, 0.05 divided by 12. The number of times we earn interest is going to be 12 times 20 because we're going out 20 years. Our payment, though, is 0. So we're no longer putting any money each month in, but our starting amount at the beginning of that 20 years is $26,492.17. And a little reminder, don't put a comma in with big monetary amounts like this. A spreadsheet will misinterpret the comma. So if I enter this amount in, what we'll see, and here's my screenshot from Google Sheets, is that we end up with $71,000 at the end of those 20 years, and that is actually how much we have after all 30 years, because this incorporates what we had in the account at the end of 10 years. So we don't need to think about that anymore. Our total amount in 30 years does include all of those deposits, that initial $100,000, and every amount you've earned over the course of the time period. So that $71,863.73 is what we now have after 30 years. Now in scenario number 2, we're going to do this almost backwards. We're still going to start with $1,000. So in our first 10 years, we start with the $1,000. So $1,000 to start. But we're not going to deposit money for a while. If you read through this in the scenario 2, I say you start with the 1,000 and you just leave it there earning interest for 10 years. So no monthly deposits. Okay, so if we leave it there for 10 years, that means we're going to look at our future value at the end of 10 years by taking the interest rate, 0.05 divided by 12, looking at how many years and particular times periods we earn interest with, which would be monthly for 10 years, so 12 times 10. We have no monthly deposit, and we're starting with $1,000. So putting that into a spreadsheet, in my case Google Sheets, here's the screenshot from that. What we end up with after 10 years is $1,647.01. That's much lower than what we had in the first scenario, but in the first scenario we were putting monthly deposits in. Here we weren't, so we just left that $1,000 alone. But we are going to start putting monthly deposits in. After 10 years, we're going to put that same $160 each month in, and we're going to do it for 20 years. So we're actually going to put more money in this next 20 years. So the remaining 20 years, we're going to put that $160 in each month. So $160 per month. So let's work out with our future value formula how much we will have. So our future value, 0.05 divided by 12 is our rate. We're now going out 20 years, so 12 times 20, because we're earning interest compounded monthly. And we now have a deposit of $160. Now you might be tempted to start at 1,000 because that kind of repeats what we did before, but remember we now have more than $1,000 in the account. So we're starting with $1,647.01. So we're going to plug this in to our spreadsheet. Here's a screenshot of that. And I used Google Sheets, and Google Sheets returns that I end up with $70,233.13 in the account after 30 years. Okay, it's 30 years because I went 10 and then 20 more. So that's how much I have at the end of all 30 years. Remember, it incorporates the 1,647, so there's no reason to add that in. That's all incorporated in. All of my deposits as well as the amount that I earned in interest, both in the first 10 years and in the remaining 20. Let's compare these two scenarios. In the first scenario, I ended up with $71,800. In the second scenario, I ended up with $70,000. Now, much better in the first scenario. And that may be surprising because if you think about it, I put much less money in. I deposited $160 per month only for 10 years. So that's $160 times 12 times 10, which ends up being about $19,000. And then with the initial $1,000 ends up being just over $20,000 that I've deposited in the account. It comes out to $20,200 when you add that 1,000 in. When we compare that with how much I put in the second scenario, I was depositing money, specifically $160 a month for 20 years. That $160 for 20 years would be $160 times 12 times 20. That's double the amount of monthly deposits that I made in scenario 1. And when you add it to the 1,000 that we started with, that ends up being $39,400. I've actually put in, as I mentioned, almost twice as much money in scenario 2 and earned less after 30 years. I've actually only have 70,000 in this account, even though I put more money in, compared to in scenario one where I just deposit that money early. Again, early is the key. The more time you can let compound interest work its magic on that money, the better off you are. So this example really shows clearly, because I started with the same amount in both, but in one I made deposits early on, in the other one I made deposits later on, and I get close to the same amount, but ended up putting double the amount of deposits in the second scenario where I was depositing later. So again, early when you're saving is better, even if you can just do a little bit, a little bit. And of course, most of us, we may not be able to deposit the same amount each month over the entire course of 30 years. Maybe some years we do $10 a month, other years we aren't able to, but any little amount you make, and maybe in later, year 20, you're able to put $200 a month in, but any little amount that you can put in early is going to make a difference.